Okay, Math for College, we've got a couple more lessons left. This one is on factoring the sum and difference of cubes. So if you see perfect cubes in this situation, like a cubed plus b cubed, let's just remember what cubes are. So, for example, if you're looking at squares, so I'll write n squared. If you were to take, actually, I'll write it down here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth. So if that's n, if we were to square that, the perfect squares are 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, and 9 squared is 81. But if you were to cube those, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. 7 times 7 times 7 is 343. 8 times 8 times 8 is 512. And 9 times 9 times 9 is 729. So there's you can put 10 on here and you'd have 100 and 1,000. So these are what we call our perfect squares, and these are what we call our perfect cubes. So if you have two perfect cubes that are added together, they factor. And here's how it factors. The cubed root of a cubed is a, and the cubed root of b cubed is b. Then you square a to get a squared. You square b to get b squared. And you multiply the two together, ab, to get the middle. So you can see you have a binomial and a trinomial that it factors to. Now there's signs that go along with here. As you can see, a plus in the original problem, you have a plus here. You always have a plus on the end. This sign here is opposite what you see for the original problem. So if you have a cubed minus b cubed, let's see if we can anticipate what this is going to be. You still have the a and the b. Square the front, square the back, multiply the two together for the middle. Now, since it's minus, you're going to have a minus there. The back is always plus, and the middle is opposite what you began with, so plus. Okay, so this is factor the following sum and difference of cubes. So here I have the difference of cubes. So I look at the cubed root of x cubed. What multiplies to x cubed? And that's going to be x. What multiplies to 8? 3 times multiplies to 8 would be 2. Square the front, x squared. Square the back, 4. Multiply the 2 together, 2x. Back is always plus. The front is the same as what it starts with, and then this is opposite that sign. Uh-oh, this one looks tough. It's another subtraction one. What multiplies to 27? That would be 3. And then b to the 6th, b squared. If you multiply b squared together 3 times, you're going to get b to the 6th. How about 125? We're going to have 5. C to the 1st power and d to the 3rd power. Square the front, 9, b to the 4th. Square the back, 25, c squared, d to the 6th. Multiply the 2 together, 15, b squared, cd cubed. It's subtraction there, so it's subtraction here. Back is always plus. This is opposite what the original sign is. So there's sum and difference of cubes. The other one we want to look at is our grouping option. Grouping often works when you have 4 terms. As I gather those terms together, I don't see a common factor that's listed throughout the entire piece. So I don't see an x existing throughout all the terms, nor is every term divisible by 2 or by 4. For example, in this group here, they're all divisible by 2. And in this group here, they are all divisible by x. As I look at the whole group together, they don't all have one common factor. But if I group 2 together, this is going to work out quite nicely. Notice that here you can take out an x squared. And as you take out an x squared, you're left with x minus 10. And for the next one, you can take out a 4. And you're left with x minus 10. So what we're going to do now, I want you to picture this expression here. Suppose it was x squared y plus 4y. What you do is you would factor out the y, and you'd be left with x squared plus 4. So instead of a y, we have x minus 10. So I'll take out that x minus 10, and I'm left with x squared plus 4. The sum of 2 squares does not factor, so we're going to leave that alone. Another one, we can factor this, y cubed minus 4y squared, but we don't like to put a parenthesis down in front of a subtraction sign. So the reason why is if you put a parenthesis here, then instead of this being a positive 16, it becomes a negative 16. It changes the problem. So we're going to do a plus negative 4y plus 16. So just change it to add the opposite. And when I do that, I can now put my parentheses down. For factor out of y squared, and you're left with y minus 4. The common factor for the next one is going to be negative 4. I factor out a negative 4, and left with y minus 4. In these situations now, you can factor out the y minus 4, because they share that in common. You're left with y squared minus 4. Now, the problem up above, you had the sum of 2 squares. That didn't factor, but the difference of 2 squares does. Y minus 2 and y plus 2. And there you have it, folks. So there is your introduction to your grouping, as well as your sum and difference of cubes. You should be able to complete that work now. And we'll move on then later on to our very last one, which is solutions to polynomials by factoring.